how to balance redox reactions in acid and alkali conditions. In this video, I'm going to take you through several steps in order to solve redox equations, balance redox equations in both acid and alkali conditions. Firstly, I'm going to show you how to do it in acid conditions using the following equation. It's chromium oxide plus nitric acid to chromium ions and nitrate ions. The first step we've got to do is to separate into half equations. In order to separate an equation into half equations, you simply look at what atoms that aren't H or O on either side of the equation and what molecules they're in, and then you put them together. So in this case, this means putting chromium oxide and chromium ions together, and nitric acid and nitrate ions together. Next up, you're going to balance the elements that aren't H and O. This just means, in this case, doubling the number of chromium ions and doing nothing to the nitrate side. For the third step, we're going to balance the oxygen using the water. And in order to do that, we add 7H2O to the right side of the chromium equation, and we add 1H2O to the left side of the nitrate equation. Our fourth step is to balance the hydrogen by adding protons. In this case, we're adding 14 protons to the left side and 3 protons to the right side of the nitrate equation. For step number 5, we're going to balance the charge by adding electrons. In order to do this, you simply look at the sum of the charges and, well, make it so that both sides are equal by adding however many electrons you need to whichever side. In this case, we're adding 6 electrons to the left side of chromium, as the right side without electrons is +6 and the left side is +12. So adding 6 electrons makes them equal. We're also adding 2 electrons to the right side of the nitrate equation. This should be fairly self-explanatory. Finally, we're going to multiply the equations so that both half equations have equal numbers of electrons. This is so that when we combine the equations later, the number of electrons cancel each other out, as electrons, at least in chemistry, don't exist on their own. They always exist as part of an atom or ion. So in this case, we are multiplying the nitrate equation by 3 so that it has 6 electrons on the right side to balance out the 6 electrons on the left side of the chromium equation. Finally, you recombine the two half equations. This is a lot simpler than I think these long equations make it look. I've simply put the two equations we did earlier down top, and then I've shown what they would look like if you just straight up combine them. We're going to simplify this, as you can see that the water atoms on both sides will cancel each other out, and as will some of the hydrogen ions, and of course we've already made it so that the 2 electrons will cancel each other out. This gives us a final equation of 3HNO plus 5H plus chromium oxide rather, and 2 chromium ions, 4H2O, and 3NO3 minus. And that is how you balance redox acid conditions. Now for alkali conditions, we do many of the same steps. In fact, we do all of the same steps, there's just a final step that's different. So I'm going to very quickly go through all of this, even quicker than I did before. I know, I'm really going quickly today. Firstly, we're going to separate into half reactions this equation. So it's silver plus zinc into silver oxide plus zinc. This is very simple because, again, silver on both sides, so we put the silver atoms together, and we put the zinc atoms together. Then we balance the elements that aren't H or O, which is, well, oh, I've done this incorrectly in my PowerPoint. That should be 2 silver. Well, you know now. Moving forward, we're going to balance O using H2O. Yeah. So just be clear, this should have a 2 in front of it. I missed that earlier when I was making this PowerPoint, but it is currently 47 minutes past midnight, and I can't be bothered to change it, so it's staying as is. Next up, we're balancing zinc. This is very easy. It's just got a simple charge. For our fourth step, we balance the H using H+. Again, we're doing nothing for the zinc. We're just changing the silver. We're adding 2H+ to the right side of the silver equation. And for zinc, yeah, nothing changes. We balance the charge using electrons. This is very simple, as the left side of silver has 0 charge and the right side has 2+, so we just add the 2 extra electrons to balance it out, make them both sides equal 0, and we do the same with the zinc, except on the other side. Multiply the half equations until they have the same number of electrons. This is, I mean, they both have 2 electrons. What do you want me to say? We don't have to multiply them by anything. So with our equations nice and ready, we can simply combine them. I've not gone through the whole process of showing you what cancels out what, although in this case it's just that the 2 electrons cancel each other out. And finally, since it is in alkali conditions, we are going to add hydroxide ions to both sides in order to cancel the H+ and turn it into water. So in this case, that water that was on the left side has been cancelled out as 2 water molecules were made, since we added 2OH to both sides of the equation. This has also added 2OH to this side, as there were no hydrogen ions to turn it into water. Right, that is how you use redox reactions to do alkali conditions. And in summary, here are the 8 points you should use. I should note that if you go to the same school as me and you know me personally, we do not need to do step 8, as you will never be asked to balance alkali conditions, as far as I'm aware. I haven't covered every paper, and for all I know, the examiners are just going to throw something at us. But yes, if you're doing OCR Chemistry B, you do not need to know step 8. Thank you very much for watching and for putting up with my tired ass, and I'll see you all in the next video.